Hi Poema, I have your test here, so we're going to go over the questions that you missed. So the first one says a spinner is divided into 8 equal sections. Each section contains a number from 1 to 8. What is the probability of the spinner landing on a number that is greater than 5? So you chose 1 out of 8. I'm not sure if you just read that as of the spinner landing on 5, but this is a number greater than 5. And the numbers that are greater than 5 of the numbers 1 through 8 are 6, 7, and 8. So there are 3 numbers that are greater than 5, and there are 8 numbers altogether, so it's 3 eighths. This shows the marbles in a bag, 1 blue, 2 green, 3 yellow, and 3 red, which best describes the complement of choosing a red marble. So when we talk about complement, we're talking about basically what it would be if we weren't choosing a red marble. What are our options if it's not red? So here the complement of red is everything that's not red. So that would be blue, yellow, or green. It looks like you picked yellow maybe because there's 3 reds, so there were 3 yellows. But complement again means all of the choices that aren't choosing red. Lewis is rolling a 10-sided die 250 times. Each side of the die is labeled with a number 1 to 10. Based on the theoretical probability, how many times would Lewis be expected, to roll a multiple of 3? So first let's talk about this in a numbered die 1 through 10. The numbers that are multiples of 3, 3 times 1, 3 times 2, and 3 times 3. So 3 out of 10. And he is going to roll it 250 times. So we can set up a proportion. 3 out of 10 would be the experimental probability that he rolls a multiple of 3, but we're going to do this out of 250. So when we set up a proportion, 3 over 10 is the same as how many out of 250. So we're going to cross multiply. 10x equals 750, and dividing both sides by 10, we get x equals 75. So there we go with that answer. You could also do 3 divided by 10 in a calculator. 3 divided by 10 is 0.3. So you have a 0.3 or a 30% chance of rolling a multiple of 3. And then you can take that 0.3 and multiply it by 250, and you will also get 75. So kind of 2 different ways there to solve that one. Juanita rolls a number cube x times. For which value of x are the experimental and theoretical probability most likely to be equivalent? So remember, back from that previous video where there were several questions like this that you missed, the more times you do an experiment, the closer you get, or the closer you get to the theoretical probability from the experimental. So the more times you repeat the experiment, the closer or the more or the same those 2 numbers will be. So experimental and theoretical probability are more likely to be equivalent or equal the more times you do it. So it's always just going to be the biggest number in questions like that. Spinner with 4 colors is spun for a total of 50 trials. Yellow was selected 10 times. What is the experimental probability of it landing on yellow? So that was 10 out of 50. It asked for experimental. So in the experiment, it spun 50 times. It landed on it 10. That's 10 out of 50, which reduces to 1/5. You picked 1/4. That's the experimental probability with 4 colors. All of them being equally likely. Yellow is 1 out of the 4, but it didn't ask for the theoretical probability. It asked what happened in the experiment. Gerald is conducting an experiment with 3 possible outcomes. Casey is conducting an experiment with 20 possible outcomes. Which statement best relates the possible outcomes to the number of trials needed to produce results similar to their predicted outcomes? Gerald will need to conduct more trials than Casey because there are fewer possible outcomes in his experiment. No, that's the opposite. So with fewer possible outcomes, you have to do the experiment a fewer number of times. Right? So let's say I've got 3 marbles in a bag and they're all a different color, or I have 20 marbles in a bag and they're all a different color. If I only draw out 6 times, the bag that has 20 marbles in it that are all different colors, there are gonna be lots of marbles there that I never ever pick, and we know that probability shouldn't be 0. So when there are fewer outcomes, you have to do it fewer times, right? When you have more outcomes, you have to repeat that experiment more times so that you can get, it says it wants to best relate the possible outcomes to the number of trials needed to produce results similar to predicted. So this is, we want theoretical and experimental to be close. We know that we need to do more of the experiment, but if you have fewer outcomes, you don't have to do it as many times. So Casey would certainly have to do more trials because she has more outcomes. Theoretical probability of an event occurring is 2/5, which best describes the experimental probability associated with the event. So we don't ever want to say exact. That's the trick here. You chose that out of every 5 trials, the desired outcome will occur exactly 2 times. Well, that's in theory, but we also know that if I flip a coin twice, it's not necessarily going to land on heads once and tails once. It could land on heads twice. So we don't ever want to say exactly. We want to say approximately or around 2 times, about 2 times, but we don't want to say exactly when we're talking about an experiment, because it's never going to be exact. I mean, I guess it is, but not as often as we think. It'll be close, but not exact. Kyle's handful of trail mix has 2 almonds, 4 peanuts, 3 raisins, 5 sunflower seeds. He picks one from the handful. What's the probability that's a peanut? So we have 4 peanuts out of how many total items? 2 plus 4 is 6. 7, 8, 9. 9 plus 5 is 14. 4 out of 14 reduces to 2/7. Michael practiced batting and kept track of his hits. He missed 2 and hit 8. How many balls can Michael predict to hit if he's pitched 20? So we have to be careful here because he misses 2 and he hits 8. That means in total he had 10 balls. And he hits 8 out of 10, or 80%. So we want to know how many will he hit out of 20. So 10x equals 160. Divide both sides by 10. Again, this is just basic proportion solving. We get x equals 16. Also 8 out of 10, if you do 8 divided by 10 in a calculator, you get 0.8. And if we take 0.8, again, I'm just showing you a second way to solve this, times 20, you will get 16. The answer you selected is how many he would miss. If he missed 2 out of 10, then we would predict 4 out of 20, but it said how many is he predicted to hit. Soap factory randomly inspects 100 bars of soap to better identify problems. The table below shows the possible problems and frequency. If the soap factory makes 5,000 bars of soap per day, how many of those bars would they expect to be broken? So we have 3 out of 100 that are broken. So how many out of 5,000 would we expect to be broken? So we're going to do 3 times 5,000 and 100 times x. And divide both sides by 100. So we would expect 150 bars to be broken. Mariah has a spinner. It has 10 equal sections, each containing a different number from 1 to 10. She determines how many times the spinner will land on a number that's greater than 7 in 250 spins, and her work is shown below. What mistake did she make? So numbers that are greater than 7 are 8, 9, and 10. So that's 3 numbers out of 10. And for some reason she has a 4 here. She must have maybe counted the number 7, but we're looking for numbers greater than 7. So Mariah should have used a 3 in the numerator because there are only 3 numbers that are greater than 7. Yeah, so we're doing 3 divided by 10. Multiplying that by 250 would tell us how many times it would land on the spinner, or land on a number greater than 7 out of 250 spins. It doesn't even ask us to solve it. It just says what's her mistake. So again, she should have had 3 out of 10. Prisha rolls a fair number cube multiple times and records the result of each roll. Her results are shown in the table. How does the experimental probability of rolling a 3 compare with the theoretical probability of rolling a 3? So we know in theory it should be 1 out of 6. Okay, this is theoretical. But here we can see 24 out of, now we have to add up all those rolls because it doesn't tell us anywhere. So we have to add 18 plus 16 plus 24 plus 26 plus 16 plus 20. So out of 120 rolls, 24 times it landed on a 3. So if we divide the top and the bottom by 12, 12 goes into both of these numbers. It's 2 over 10. And we can divide the top and the bottom by 2. I'm just trying to reduce the fractions, and we get 1/5. This is 0.2 in a calculator. Remember, this is experimental. And 1/6 is 0.16 repeating. So you can see the experimental probability is greater. Experimental probability of rolling a 3 is 1/30th greater than the theoretical probability. Experimental probability is 1/3 less. Nope. Experimental probability is 2/3 greater. No. So how do we figure that out? So you have to take 0.2 and divide it by 30. No. 0.16 and divide it by, well, it's not 2/3 greater. That would be a whole lot greater. I guess they're taking 0.2 minus 0.0333. Yeah, if you subtract these two, you get 1/30th. I can take 1/5 minus 1/6 is how they're doing this. So this is 6 over 30 minus 5 over 30 if I get a common denominator. So it's 1/30th greater. Experimental was greater than theoretical. Greater than. What that actually says is that the theoretical was less than the experiment, but by 1/30th. You get that from just subtracting the two probabilities. And then the last question says, Jason practiced making soccer goals and kept track of the results. He missed 3 but made 9, so that's 12 total. What can Jason predict regarding goals made? 9 out of 12 if it has 24 tries. So 9 over 12, and then it looks like they're multiplying by 24. That's the math they're showing you. That's really similar to the cross multiplying I was showing you earlier. You can just do 9 divided by 3, which is 0.75, multiply it by 24, and we will get 18 as the theoretical probability. Okay, so that's the test. It looks like several of those kind of proportion questions where they're taking a probability from a smaller sample and then applying it to a larger number. So there were several questions in there like that. If you have any other questions, please reach out.